Greetings, Panthers. It's Dr. Augustine. Today we're going to take a look at some examples of solution stoichiometry. So by solution stoichiometry, what we mean is things that are in the solution state and their chemical reactions that occur, and you can use the stoichiometry principles that we learned in Chapter 4 to apply them to aqueous solutions. So this is Chapter 5.3 intro, and actually extending even a little bit beyond that later into Chapter 5. And I'm just going to look at two example problems. We're going to look at one called gravimetric analysis, which gravimetric means having to do with mass. So basically, you measure the mass of a precipitate, and using the mass of the precipitate and stoichiometry principles, you can figure out how much of the reactant you had. And then the second thing we're going to look at is an acid-base reaction, specifically a titration reaction, which is the neutralization of an acid and base. There's going to be more videos later about acid bases and more example titration reactions, but this is sort of your first introduction to the concept. So let's take a look at one example problem, which is a gravimetric analysis type problem. So here's the setup. We have a 500 milliliter sample of some polluted water source, and it's analyzed for lead-2 ions. Lead-2 it would be a pollutant in water. You wouldn't want to have that in your drinking water. And the way we do this is we add an excess of sodium sulfate to it to form a precipitate. So the next section of the book deals with precipitation reactions, but when you add sodium sulfate to lead-2 ions, it forms a precipitate, and the precipitate is actually called lead-2 sulfate. And in this case, we measured this to be 229.8 milligrams of this lead-2 sulfate. So the first question is, what is the molarity of the lead-2 ions in the water sample that we started with? And what is the total mass of lead in the water in units of milligrams Pb2 plus per liter of water? These are two different units of measurement. One is molarity. That'll be the more common one we would use in the first semester of chemistry. And the second is milligrams per liter, just another concentration unit. Okay, so let's start this problem out by writing out the net ionic equation for this particular reaction. So we don't know what the Pb2 plus is in there with. We just know it's lead-2 plus. We also know that it's in solutions. That means we put a little AQ next to it, aqueous, plus sodium sulfate has the formula Na2SO4. We've not quite learned this yet. In section 5.4, we learn about the solubility rules. But one of the solubility rules we learn about is that all group 1 cations are soluble. So this should have a little aqueous next to it as well. And the sodium ions we will also learn are called spectator ions. They're not involved in the reaction. So it's only the sulfate ions that we're interested in. So I'm just going to write the sulfate ion in the reaction. So lead-2 plus sulfate yields PbSO4, and we're told it's a precipitate, so that means it forms a solid. So that's our balanced chemical reaction. And I'm going to save us a little bit of trouble down the road. I'm going to write down the atomic masses and the molar mass of these things. So this one's 207.2 grams per mole. That's the molar mass of lead, and lead sulfate is 303 molecular weight, 303.3 grams per mole. That's the molecular mass of lead sulfate. Okay, so let's come back and take a look at this problem, how we're going to attack this problem. So we know that we have 229.8 milligrams, and we're trying to find out molarity. So if you remember, molarity would be moles Pb2 plus for every liter of solution. Okay, so that's what we're looking for. So we're going to need to find the moles of Pb2 plus. We can get the liters of solution from here. We know we have 500 milliliters, so that part of the problem is going to be easy. We need to find out how many moles of Pb2 plus we have in this solution. So we precipitated lead-2 sulfate, so what I'm looking for is moles Pb2 plus, and what I have is 229.8 milligrams PbSO4. So I'm going to get that into grams. I'm going to say times 10 to the minus 3 grams for every 1 milligram. Just for the sake of completeness, we'll write all this down, PbSO4. And remember, cross off units here, milligrams PbSO4, milligrams of PbSO4. Now I have grams of PbSO4. Now I need to multiply by the molar mass. So this can be 1 mole PbSO4 for every 303.3 grams PbSO4. Grams PbSO4 cancels grams PbSO4. I have moles lead sulfate, but I want moles of ions from the water, not the precipitate. So I need to convert this into moles of ions. So this is going to be times, from the balanced equation, if we look back here, we notice they are in a 1-to-1 ratio. 1 mole PbSO4 for every 1 mole of Pb2+. Remember, that's not always going to be the case, but in this particular case it is. So we have 1 mole Pb2+ for every 1 mole PbSO4. That cancels that, and that will give me moles Pb2+. So if we calculate all this out, careful with sig figs here. There's actually 4 significant figures here, 4 significant figures here, so my answer should have 4 significant figures. So 7.577 times 10 to the minus 4 moles Pb2+. That's how many moles of Pb2+ were in the original solution. So now if we want to find the molarity of this, molarity Pb2+, remember, is equal to moles Pb2+ per liter of solution. So that's going to equal to 7.577 times 10 to the minus 4 moles Pb2+, that's what we just found, divided by our starting volume. So that would be 500 milliliters times 1 liter for every 1,000 milliliters. Remember, the units are moles per liter, not moles per milliliter. So milliliters are going to cancel milliliters, and now I will have units of moles per liter. So when we finish this calculation, we have 1.515 times 10 to the minus 3 moles Pb2+, molarity Pb2+. Okay? That's my molarity of lead 2 ions. That's part A of this problem. What is the molarity of the lead 2+ ions in the water sample? So part B is, what is the total mass of lead in the water in units of milligrams of lead 2+ per liter of water? So total mass of lead, I have the number of moles. So if I have the number of moles and I have the molar mass, I should be able to find the total mass. So let's take a look at that. So now I want mass in milligrams of Pb2+. So I'm going to use the number of moles I found, 7.577 times 10 to the minus 4 moles Pb2+, times 207.2 grams Pb2+ for every 1 mole of Pb2+. Now you might be asking yourself, hey, wait a minute, isn't that the atomic mass of lead? Why is lead 2+ the same number? Well, remember, in order to get 2+, I had to have lost 2 electrons, and the mass of the electrons is very small compared to the mass of the rest of this. So we can basically use the same mass as lead atom for the lead ion, because the electron mass is not a significant proportion. So this is going to equal to 0.1570 grams of lead 2+. And my answer I'm looking for, I want milligrams of lead 2+ per liter. So I need to convert this into milligrams. So this is going to be times 1,000 milligrams for every 1 gram. And again, just for completeness, I'll put the complete units. Lead 2+. Grams lead 2+ going to cancel milligrams lead 2+. So that's going to equal to 157.0 milligrams of lead 2+. That's the total mass of lead that we found in this 500 milliliter sample. Okay, so the total mass of lead in the sample was 157 milligrams, but this is asking for what's the mass in milligrams per liter of concentration unit. So now I need to take that. So if I want milligrams per liter, Now I need to take this number, 157.0 milligrams Pb2 plus. This will give me a concentration unit that then I can apply to really any amount of this water that I find. Milliliters times 1 liter per 1,000 milliliters. And that is going to equal to 314.0 milligrams Pb2 plus per liter. Okay, so that is a second type of concentration unit, and that means any amount of this stuff. If I have 50 milliliters, I can use this as my conversion factor to find out how many milligrams of lead I would have, or how many moles of lead I would have in that 50 milliliter sample, because that's a concentration unit as well as this being a concentration unit. So molarity is the one we use much more often in General Chemistry 1, and remember the key to doing that is you need to find the moles of whatever it is you're looking for per liter of solution. Okay, let's take a look at the second problem.